Greetings, my dear listeners. Today we embark on an unusual journey where the main character is neither a person nor a star nor even a galaxy. Our story is about something that constitutes the very fabric of the universe, yet escapes both our eyes and our instruments. We are going to talk about dark matter, a mysterious substance that, like a shadow, accompanies the entire cosmos, shaping its form and fate, while hiding in the unreachable depths of the unknown. Picture yourself gazing at the night sky, sprinkled with stars. Every dot you see is a sun, perhaps with planets, maybe even with life. We are used to thinking that everything we see is the universe. But what if I told you this is only a tiny fraction? The galaxies, stars, planets, and glowing clouds of gas, everything visible, makes up only about 5% of what actually exists. The remaining 95% lies hidden behind an impenetrable veil, and it is there that dark matter resides. But how did humanity even suspect that something beyond the visible was out there? It all started with questions. Science always moves forward through doubt. If calculations don't match, if observations don't fit the theory, then something else is happening behind the scenes. In the early 20th century, astronomers noticed something peculiar. Stars and galaxies were rotating too quickly. If galaxies contained only the matter we can see, stars and gas, they should have scattered apart like sparks flying from a fire. And yet they didn't. They held together as if by some invisible hand. This gave birth to the hypothesis of hidden mass, something that neither emits nor reflects light, something invisible yet gravitationally powerful. We named it dark matter. Let us pause for a moment. How many other secrets might the universe be hiding if even the very glue that holds galaxies together cannot be seen? Is it not astonishing that the most important element of reality is silent and concealed? One of the first to speak seriously about hidden mass was the Swiss astronomer Fritz Zwicky. In the 1930s, while studying clusters of galaxies, he noticed that their motions were far too fast to be explained by visible mass alone. He proposed the existence of dunkle materia, dark matter. His colleagues laughed at him, but time proved him right. Decades later, the American astronomer Vera Rubin confirmed his suspicions. She observed the rotation curves of galaxies and found something extraordinary. Stars on the outskirts moved just as fast as those near the center. According to Newton's laws, they should have moved more slowly, yet they didn't. Everywhere she looked, there was evidence of something invisible. Rubin showed the world that dark matter was not a myth, but a physical reality. These discoveries were a turning point. They suggested that the familiar picture of the universe, where stars are the main players, was incomplete. In reality, we live in a ghostly cosmos, where the overwhelming majority of matter is hidden. And here comes a philosophical question. Can we truly trust our eyes? Is the visible always the truth, or only the surface? Does this not resemble human life, where the deepest truths often remain unseen? We notice smiles, but not sorrows, appearances, but not essence. Perhaps this is why the cosmos and life mirror each other. Both demand from us the ability to perceive the invisible. Scientists began to construct theories. What could dark matter be? It is not stars, not planets, not dust. It does not absorb or emit light, and yet it has mass. Imagine a colossal invisible web upon which galaxies are strung. Cosmologists call this the cosmic web. Simulations show that galaxies are not scattered randomly but gather into giant filaments and nodes as if drawn by invisible strings. The scaffolding of this cosmic web is made of dark matter. Without it, the universe would lack structure. There would be no spirals of galaxies, no clusters, and perhaps not even us. And again, let us pause. Maybe dark matter reminds us that the foundation of any world is hidden. The roots of a tree are unseen, yet they sustain its crown. The foundation of a house lies underground, but it supports the walls. Is the cosmos any different? Physicists have proposed many candidates. WIMPs, weakly interacting massive particles. Sterile neutrinos, axions. Some even suggested that black holes might make up dark matter. But so far, no experiment has provided a definitive answer. It is a cosmic game of hide and seek, and so far, the universe is winning. But perhaps that is the beauty of science. It thrives on mystery, forever chasing what seems just beyond reach. Even if we see only the tip of the iceberg, that does not weaken us. It makes us seekers. In the chapters to come, we will dive deeper. We will explore the experiments built to catch dark matter particles, the theories that challenge the very laws of physics, and the story of the cosmos from the Big Bang to the present day. But for now, let us remember this. Dark matter is not just a riddle of physics. It is a lesson that the most important things in life and the universe are often those we cannot see. When we speak about dark matter, the first question that arises is simple yet profound. How can we search for something invisible? How do you hunt a ghost that leaves no trail of light and no shadow? To answer that, let us turn to the boldest quests humanity has ever undertaken. Imagine laboratories buried deep underground, hidden beneath mountains or abandoned mines. Thousands of tons of rock shield them from cosmic rays and background radiation. Inside these silent caverns stand colossal detectors filled with liquid xenon or other exotic substances. Scientists wait patiently. Perhaps a dark matter particle will slip through and collide with an atom. Such an event would be vanishingly rare, maybe once in years of observation. But if it happens, it could become the discovery of the century. Yet the hunt does not end underground. In space, telescopes scan the heavens for faint signatures of dark matter. The Fermi Gamma Ray Space Telescope watches the galactic center, hoping to catch flashes of gamma rays that might arise when dark matter particles annihilate one another. We are, in essence, straining to hear a whisper amidst a storm, hoping that whisper carries the universe's deepest secret. Philosophically, this search mirrors human life itself. We often seek meaning in the smallest signals. We look for patterns amid chaos. We wait for signs in the noise, not always sure if we will receive an answer. Yet the very act of searching makes us alive. The history of science is filled with examples of humanity learning to perceive the invisible. Once radio waves were unknown. Once microbes were hidden until microscopes revealed them. Planets beyond our solar system were only dreams until technology made them real. Dark matter is our next frontier. Perhaps in a century people will wonder how we ever lived without knowing what it is. One of the most promising candidates for dark matter particles are the WIMPs, weakly interacting massive particles. These were predicted by theories of supersymmetry, which suggest that every known particle has a heavier partner. If such particles exist, one of them might be stable, invisible, and abundant enough to explain the hidden mass. So far, no experiment has confirmed their existence, but the search continues. Another intriguing possibility is axions, nearly weightless ghost-like particles. that could exist in unimaginably vast numbers. If axions are real, they permeate the universe like invisible rivers. To detect them, scientists are building enormous radio-like detectors, tuning them to the frequency of the cosmos itself. There are also theories about sterile neutrinos, even more elusive than the neutrinos we already know. Ordinary neutrinos interact so weakly that trillions pass through our bodies every second without notice. Sterile neutrinos would be even more elusive, making them prime suspects for dark matter. And then, of course, there are radical alternatives. What if dark matter does not exist at all? Perhaps the law of gravity itself needs revision. Modified Newtonian dynamics, MOND, suggests that at very low accelerations, gravity behaves differently. In some cases, MOND can explain galaxy rotations without dark matter, but it fails elsewhere, in galaxy clusters, or in the cosmic microwave background. Most scientists still favor the existence of dark matter, yet the willingness to question even gravity itself shows how bold the search has become. Notice how science works. It does not hide its ignorance. Instead, it turns uncertainty into fuel for discovery. Dark matter is not a defeat, but a challenge. It is a locked door, and we are determined to find the key. But how long can we search? Can one devote a lifetime to chasing something that might never be found? Many scientists know they may not live to see the answer, and yet they persevere. Why? Because truth is worth more than time. Because every step, even if it doesn't lead to the final answer, makes humanity stronger. Let me share one story. In Italy, deep beneath the Gran Sasso Mountains, an experiment called Dama/Libra has been running for decades. The detectors there record a mysterious annual signal, slightly more events in summer than in winter. The scientists interpret this as Earth moving through a wind of dark matter particles as it orbits the Sun. The result is controversial. Other experiments have failed to confirm it. Yet the debate continues, showing us that science is alive as long as there are questions. Dozens of other experiments, XENONLUX, Panda X, all seek the same rare collisions. Space missions like AMS on the International Space Station hunt for traces of particle annihilation. Each attempt is like a thread weaving into a larger tapestry. Even if they don't find a conclusive answer, they give us invaluable knowledge. As Niels Bohr famously said, "An experiment is never a failure. It always teaches us how nature works." Let us pause and ask, why does this matter to us? Why chase something invisible, something we cannot use directly? The answer is simple. Knowledge itself is power. Only by knowing what the universe is made of can we understand our place in it. Dark matter is a mirror, reminding us how little we know and how much remains to be discovered. In the coming chapters, we will explore even bolder ideas, how dark matter might be linked to dark energy or to the very fabric of space and time. For now, let us remember, the hunt for dark matter is more than physics. It is a symbol of human persistence. Even if the road has no end in sight, we walk it, because seeking the unseen is what makes us human. In our previous discussions, we spoke of the hidden mass that keeps galaxies bound and of the daring hunts that scientists carry out in deep laboratories and orbiting telescopes. But to truly appreciate the role of dark matter, we must step back and take in the entire stage. the universe itself. Only then do we begin to see its most profound purpose. Imagine the universe just after the Big Bang. It was hot, dense, and filled with elementary particles and radiation. Everything was spread almost evenly, with tiny ripples, fluctuations in density, like wrinkles in a sheet. These ripples would later become the seeds of galaxies. But here is the critical point. Ordinary matter, the stuff of atoms and light, could not gather quickly enough on its own. It interacted too strongly with radiation, constantly scattering, unable to clump together. Dark matter, however, invisible and silent, began to collapse under its own gravity long before ordinary matter could. It created wells, invisible valleys in the landscape of the early universe, into which gas later fell, igniting the first stars. In this way, dark matter became the architect of the cosmos. Without it, the universe might have remained a thin mist, never forming galaxies, stars, or planets. Without it, we would not exist. To speak of dark matter is to speak of the foundation of our own being. Scientists confirmed this picture by studying the cosmic microwave background, the faint afterglow of the Big Bang. Satellites such as COBE, WMAP, and Planck measured tiny variations in this glow, like the fingerprints of the infant universe. And in those patterns, the presence of dark matter is clear. Without it, the observed structures would not match. With it, the universe's evolution suddenly makes sense. Pause for a moment and consider, what if the very foundation of reality is not light but shadow? What if our cosmic home is built not of visible bricks, but of invisible stone? It may sound poetic, but this is exactly what the evidence tells us. When computers became powerful enough, scientists began to simulate the universe. They filled virtual space with dark matter and let the laws of gravity run. What emerged astonished them. A vast cosmic web, filaments stretching across billions of light years, with galaxies forming at the intersections. And when we compared these simulations to actual observations, the match was uncanny. The universe does indeed resemble a giant web, woven not of light, but of darkness. Is this not a profound metaphor for life itself? We do not always see the forces that shape us. We do not see time, yet it carves wrinkles into faces. We do not see love, yet we feel its pull in every choice we make. Dark matter is a cosmic reminder that the unseen can be the most real. One of the most striking proofs of dark matter came from observations of the Bullet Cluster, a collision of two galaxy clusters. When the clusters crashed into each other, the ordinary matter, the hot gas, slowed down, colliding and heating up. But the gravitational map showed that most of the mass passed through unaffected. Dark matter did not collide. It simply moved on like a phantom army. This observation was a revelation. Gravity itself confirmed that dark matter is separate from ordinary matter. It is not just a tweak of the law of gravity. It is something real. Consider the scale. In every cluster of galaxies, the majority of mass comes from dark matter. It is the invisible glue that holds the largest structures together. Without it, the universe would fly apart. The scientists who uncovered these truths were often met with skepticism. Fritz Zwicky, as we mentioned, was mocked for his bold claims. Vera Rubin spent years collecting data to convince the world. Today, thousands of scientists work together across the globe, all pursuing this mystery. This is how truth emerges, through persistence, patience, and cooperation. Let us ask a philosophical question. What would the world be like without dark matter? There would be no galaxies, no stars, no carbon chemistry, no life. In a very real sense, darkness gave us light. Is that not poetry written into the fabric of existence? Modern cosmology gives us precise numbers. About 27% of the universe is dark matter. About 68% is dark energy. And only about 5% is ordinary matter. These numbers are humbling. Everything we have ever seen, every story, every life, all of it belongs to the minority of existence. The true universe is far stranger and larger than we can imagine. Scientists continue to refine their observations, studying gravitational lensing, the bending of light by unseen masses, and mapping the distribution of galaxies. Each observation strengthens the case for dark matter. The puzzle is incomplete, but the picture grows clearer with time. And here comes another question. If the foundation of the cosmos is invisible, should we not train ourselves to see with more than our eyes? Should we not listen with reason, imagination, and humility? The story of dark matter in cosmology is the story of how the unseen became central. It is the story of how shadow built the stage upon which light can shine. The stars we love to gaze at are only possible because an invisible web holds them in place. In the next chapter, we will explore the many competing ideas about what dark matter actually is. From particles predicted by supersymmetry to radical alternatives that rewrite the laws of physics, we will see how human imagination stretches to grasp the ungraspable. For now, let us remember. Without darkness, there would be no stars, and without mystery, there would be no wonder. In the previous chapter, we saw how dark matter shaped the cosmos, building the great cosmic web that gave birth to galaxies and stars. But this naturally brings us to the next great question. What is dark matter actually made of? What are the hypotheses that scientists have built to explain its mysterious nature? Let us begin with the most popular candidate. WIMPs, weakly interacting massive particles. The idea of WIMPs arose in the 1980s, when physicists realized that if such particles existed, with certain properties, they would naturally be produced in the right abundance during the early universe. This so-called WIMP miracle made them attractive candidates. WIMPs are hypothesized to be massive enough to generate gravity, but interact so weakly with ordinary matter that they evade detection. They could slip through stars, planets, and us without leaving a trace. For decades, experiments have been designed to catch them, but so far, no conclusive signal has appeared. Another fascinating contender is the axion. Originally proposed to solve a problem in quantum chromodynamics, axions turned out to also be good candidates for dark matter. They are incredibly light, but could exist in enormous numbers, forming a kind of invisible field that fills the universe. If axions exist, they might be detectable through their interaction with magnetic fields. Experiments designed to detect them look like giant radio receivers, listening for the faintest cosmic hum. There are also more exotic ideas. One of them is sterile neutrinos, hypothetical cousins of ordinary neutrinos. Ordinary neutrinos are already extremely elusive, passing through the Earth and our bodies in unimaginable quantities every second without a single trace. sterile. Neutrinos would interact even less, making them nearly impossible to detect. But if they exist, they could account for the hidden mass of the cosmos. And then there are the truly radical possibilities. What if dark matter is not a particle at all? What if it is a sign that our laws of gravity need modification? Some physicists argue that at very low accelerations, Newton's law of gravitation might behave differently. This idea, known as modified Newtonian dynamics, can explain certain galaxy rotation curves without invoking dark matter. But it fails in other areas such as the behavior of galaxy clusters or the structure of the cosmic microwave background. Most scientists remain convinced that dark matter exists, but the mere fact that gravity itself is questioned shows the scale of this enigma. Philosophically, we face a choice between two paths. Either we say, there is an invisible substance we must discover, or we say, the laws of nature are not what we thought and must be rewritten. Both paths require courage. The courage to search for what hides, or the courage to challenge the very foundation of physics. Which kind of courage do you find more compelling? Each new hypothesis inspires new experiments. Across the world, in the United States, Europe, China, and beyond, scientists build detectors capable of sensing the faintest interactions. Some wait patiently in deep underground labs, shielded from radiation, their tanks of liquid xenon prepared to record a rare collision. Others tune their instruments like cosmic radios, hoping to catch the whispers of axions. Still others use telescopes to map gravitational effects on light. Together they form an orchestra, each playing its own part in a grand symphony of exploration. And yet, the symphony has not yet played its decisive note. Dark matter remains silent. It refuses to reveal itself. And perhaps, in that silence, there is something profound. Maybe the universe is waiting for us to learn how to listen better. The history of physics shows that the greatest discoveries often arrive unexpectedly. Electricity was once a curiosity, with no clear purpose. Radio waves seemed like an abstract idea before they changed communication forever. Even the atom was considered indivisible until deeper layers were revealed. Each discovery reshaped humanity. Who can say what discovering the nature of dark matter will bring? Let us pause and reflect. Why does it matter so much to us? Could we not live perfectly well without knowing what dark matter is? Perhaps, but human beings are not content with surfaces. We want to understand the roots, the connections, the hidden causes. This hunger for knowledge is what drives us from caves to the stars. If we settled only for the obvious, we would never have crossed oceans or looked beyond Earth. Dark matter is not just a physical puzzle, it is also a symbol of our desire to peer into the unseen. In this sense, science becomes close to art and philosophy. Do poets not search for hidden meanings? Do artists not strive to depict the invisible? Science, too, is a quest for the unseen, and dark matter is its ultimate muse. We stand at the threshold of new discoveries. The next decades may bring answers, or they may raise even deeper questions, but either way, the journey itself will change us. Even if dark matter turns out to be something completely unexpected, we will have learned more about nature and ourselves. In the next chapter, we will explore the experiments already underway, the results they have given, and the surprises they hold. We will descend again into underground labs and soar into orbiting telescopes to witness how humanity searches for the invisible. For now, let us hold this question open. Is dark matter a new particle or a new law of nature? In the last chapters, we considered theories and ideas about what dark matter might be. Now let us descend closer to Earth, literally underground, where some of the most extraordinary experiments in human history are unfolding. Here, in silent caverns beneath mountains and deep within old mines, humanity builds cathedrals of science dedicated to capturing the invisible. Why underground? The answer is simple: silence. On Earth's surface, we are constantly bombarded by cosmic rays and particles that create a background noise too loud for delicate experiments. To escape this storm, scientists go deep beneath rock, where kilometers of Earth serve as a shield. In this quiet darkness, massive detectors wait, filled with liquid xenon or argon, hoping to catch a fleeting signal from a passing dark matter particle. One of the most famous projects is XENON, located in Italy's Gran Sasso Mountains. Imagine a vast tank of liquid xenon surrounded by ultra-sensitive sensors. If a dark matter particle collides with a xenon atom, it might produce a faint flash of light and a tiny electric pulse, so faint, in fact, that distinguishing it from noise is a monumental task. Yet within such fragile traces may lie the key to the universe's greatest mystery. Similar projects operate across the world. Lux Zeppelin in the United States, Pandax in China, all are searching for the same thing, the rarest of interactions, a brush between dark matter and ordinary atoms. This global hunt resembles the alchemist's search for the philosopher's stone. We chase something invisible, yet we believe it shapes the entire world. Here arises a philosophical reflection. Is not life itself like these experiments? We too wait for rare moments that change everything, moments of love, of inspiration, of revelation. Surrounded by the noise of daily existence, we try to catch the spark that makes it meaningful. Science and life share the same rhythm: patience, attention, and faith in the unseen. But the hunt for dark matter is not limited to underground vaults. In space, telescopes search for indirect signs. The Fermi Gamma Ray Telescope watches the galactic center, hoping to see bursts of light from annihilating dark matter particles. Other observatories track cosmic rays, searching for strange excesses that might betray invisible origins. The signals are uncertain, the interpretations debated, but the effort itself reveals our determination to listen for the universe's faintest breath. One story stands out. At the Gran Sasso Lab, another experiment called DAMA/LIBRA has been recording data for decades. Its detectors consistently show a seasonal variation in signals. The team interprets this as Earth moving through a wind of dark matter, sometimes heading against it, sometimes with it. If true, this would be stunning proof. Yet no other experiment has confirmed it. For years, the scientific community has debated: is DAMA/Libra seeing dark matter or just noise? This debate is a vivid reminder that science is never final. It is a dialogue, alive and ongoing. Think of the patience required. Scientists spend years building detectors, running them, analyzing endless columns of numbers. Most days bring nothing but background noise. Yet they persist, believing that somewhere among the noise lies a single event that could transform our understanding of the universe. This patience is not unlike meditation, the art of listening to silence, waiting for a whisper. But gravity offers another route to detection. Since dark matter does not shine, we detect it by its pull. Through weak gravitational lensing, the bending of light by unseen masses, we map its presence. Distant galaxies appear distorted, as though seen through a warped lens, revealing the contours of invisible matter piece by piece. A cosmic puzzle emerges. We do not see the hand itself, but we see the marks it leaves. And is this not again a metaphor for human experience? We rarely see the forces that truly shape us. We do not see time, yet we notice its trace. We do not see love, yet we see its effects. Dark matter, like these hidden forces, reveals itself only in reflections and consequences. Consider the scale of human effort. Beneath mountains, tanks of xenon wait in darkness. Above Earth, satellites sweep the sky. On the ground, particle accelerators crash atoms in hope of glimpsing the unseen. Thousands of people in dozens of countries work together for one goal. In this way, dark matter becomes a symbol of unity. The mystery belongs to no single nation. It is the question of humanity itself. In the chapters to come, we will look further into the unexpected, the possibilities that dark matter is not just a particle, but something stranger, perhaps connected with other cosmic enigmas. But for now, let us remember, the search for dark matter is not only about physics. It is about patience, about faith, about listening to the quiet voice of the universe hidden in the silence of the earth. We have already ventured into underground laboratories and orbiting telescopes where the hunt for dark matter unfolds. But the search does not stop there. Humanity has built another tool of unimaginable power, particle accelerators. These machines allow us to recreate the conditions of the early universe and to see what emerges when matter is pushed to its limits. The most famous of these is the Large Hadron Collider, straddling the border between France and Switzerland. Its tunnels stretch for dozens of kilometers underground, where beams of protons are accelerated almost to the speed of light. When they collide, they unleash bursts of energy so great that new particles are born. Among those fleeting sparks, scientists hope to glimpse hints of dark matter. How could this happen? If dark matter is made of new particles, collisions might produce them. But since dark matter interacts so weakly, these particles would escape the detectors, leaving no trace. What scientists look for instead is missing energy. Moments when momentum and energy seem to vanish as if carried away by invisible hands. Such disappearances may be the footprints of dark matter. So far, results remain cautious. We have discovered the Higgs boson, a milestone of the Standard Model, but no clear shadow of dark matter has appeared. That does not mean it does not exist. It may mean we need higher energies, more data, or entirely new approaches. Future accelerators, even larger and more powerful, are already on the drawing board. Perhaps there the mystery will finally crack open. But particle accelerators are not only about hunting dark matter, they are about philosophy. Our attempt to return to the very beginning. By smashing particles together, we recreate the first moments after the Big Bang. We peer into the furnace where the laws of physics themselves were forged. If dark matter was born in those first seconds, accelerators may be our only chance to meet it again. Ask yourself, why do we invest billions of dollars and decades of effort into chasing something we cannot see? The answer lies in human nature. We cannot live without questions. We cannot rest until we climb the next peak, even if we don't know what lies beyond. Dark matter is that peak, the summit we are drawn to, because to ignore it would be to ignore the very structure of reality. The story of accelerators reads like an epic. The first machines were tiny compared to today's giants. Each generation pushed boundaries, and now we construct machines the size of cities. What does this say about human hunger for knowledge? We create artificial lightning, tearing matter apart, just to glimpse the secret hidden billions of years ago. That is both madness and magnificence. And yet, even if accelerators reveal dark matter particles, the question remains, what does that mean for our worldview? Perhaps we will uncover new symmetries in nature. Perhaps we will realize the standard model is only a fragment of a deeper theory. Or perhaps we will find that our understanding is even more incomplete than we dared imagine. Philosophers often say knowledge is an island surrounded by an ocean of the unknown. The larger the island, the longer its shore. So it is with physics. The more we learn, the more mysteries emerge. Dark matter expands the shoreline, revealing an even deeper ocean beyond. But let us not forget, accelerators are not just machines. They are also people. Thousands of scientists from across the world work together, united by a common goal. They speak different languages, but share the same vision. It is like a great expedition, not to the stars, but to the heart of matter. And it is just as important, because it seeks the roots of everything. Think about it. What would it mean to discover a dark matter particle? It would not just be a scientific checkmark. It would mean understanding how the universe is built, why galaxies hold together, why we exist. It would answer a question that humanity has asked since the dawn of thought: what is the world made of? But what if accelerators find nothing? What if dark matter slips through our fingers? Even then, the lesson is profound. We would know we searched in the wrong place and must look elsewhere. Science advances not only through answers, but through the courage to change direction when the road ends. In many ways, this search is deeply human. We are wanderers crossing a desert, sometimes seeing mirages but never losing hope. Each experiment is a step forward, even if it does not reveal the final destination. The journey itself gives us meaning. In the next chapter, we will turn to philosophy once more. We will ask how the idea of dark matter reshapes our view of existence, because this mystery is not only about physics, it touches metaphysics. What does it mean for something to exist if 95% of reality is hidden from sight? We have explored how scientists seek dark matter with detectors and accelerators. But now let us pause and shift our perspective. Beyond physics, beyond equations, dark matter opens doors to philosophy. It forces us to ask not only what the universe is made of, but also what it means to exist. Consider this. If 95% of the cosmos is hidden, what does that say about our sense of reality? We live our lives as though the visible is all there is. We trust our senses. We trust what we can touch and see. But dark matter whispers another truth. The visible world is only a fraction. Reality is far larger than our eyes admit. Does this not sound like Plato's allegory of the cave, where people mistake shadows for reality? Today, science repeats this parable. We watch the glitter of galaxies, but they are only shadows of deeper structures. Vera Rubin, who gave us some of the clearest evidence for dark matter, once said, "We don't know what it is, but it comprises most of the universe." Her words carried not despair, but awe. This is the essence of science, to face the unknown with humility and wonder. Philosophers have long debated what it means to exist. If something cannot be seen, yet exerts influence, is it any less real? Dark matter challenges the border between visible and invisible. It tells us that existence is not confined to the senses. It tells us that truth is broader than perception. Think of music. We hear melody, but behind it lies the invisible physics of vibration. We feel emotions, though we cannot measure them with eyes. In the same way, we see the music of dark matter, galaxies rotating, light bending, cosmic webs forming, but the instrument remains hidden. This is a reminder that reality often reveals itself through effects rather than direct presence. Could it be that dark matter is not merely a physical concept, but a lesson? A lesson that the unseen always outweighs the seen. That mystery is not an error, but a feature of existence. The cosmos becomes a teacher, reminding us that knowledge will always encounter horizons. Artists, poets, and philosophers have been inspired by this idea. Dark matter appears in novels, paintings, and symphonies. It is not only a scientific hypothesis, but also a metaphor for hidden truths. In literature, it becomes a symbol of memory, of trauma, of love, forces invisible but real. Science and art converge in this shared insight. The invisible shapes the visible. But let us not confuse darkness with evil. Darkness here is not an enemy, it is the womb from which light emerges. Night allows us to see the stars. Silence allows us to hear music. Emptiness allows form to exist. Dark matter, too, is not a threat, but a foundation. It sustains galaxies, holds the universe together, and indirectly gives birth to life. So let us ask ourselves, can we live without knowing? Yes, we can. Humanity has survived millennia in ignorance of dark matter. But can we thrive without asking? Number. To live fully is to ask questions, even when answers are distant. In this sense, dark matter is less a puzzle of physics and more a call to wonder. And there is another lesson: humility. We often think humanity is the crown of creation, that we understand the world. But the truth is, we are still children, holding a key, without knowing which door it unlocks. Dark matter humbles us, reminding us that we are at the beginning, not the end of the story. Spiritual traditions across cultures echo this theme. Buddhists speak of emptiness, Christians of invisible grace, Greeks of the world of forms. All these ideas suggest hidden layers of reality. Science without meaning to brings us back to these same questions. What is real? What is hidden? Is the border between them absolute? Perhaps dark matter is a bridge between physics and metaphysics. It is measurable, its effects undeniable, yet its nature remains secret. It forces us to consider that reality is multi-layered, that the cosmos is not exhausted by equations. And perhaps, just as the universe hides its mass, we too hide parts of ourselves. Our thoughts, our dreams, our inner lives, invisible but no less real. Is it possible that we ourselves are made not only of atoms but of hidden dark matter, of the soul? That the unseen within us is as crucial as the flesh we see? These are not scientific questions, but they arise naturally once we face the hidden cosmos. In the coming chapters, we will return to physics, to dark energy, to black holes, to the boldest experiments. But let us carry this reflection with us. Dark matter is not only an astrophysical concept, it is a mirror held up to humanity. It reminds us that most of what matters in life cannot be seen, only felt, inferred, or believed. And perhaps that is the greatest truth of all. We have spoken much about dark matter, the hidden scaffold of the universe. But now it is time to set it alongside another enigma, dark energy. Though their names sound similar, these two mysteries are profoundly different, and together they make up nearly the whole cosmos. Dark matter pulls, it holds galaxies together, weaving the cosmic web. Dark energy pushes, it drives the expansion of the universe faster and faster. Imagine two invisible hands, one drawing everything inward, the other stretching everything outward. The universe is balanced between them, a grand cosmic tension. The discovery of dark energy came at the turn of the 21st century. Astronomers were studying distant supernovae, stellar explosions so bright that they can be seen across billions of light years. Because their brightness is predictable, they serve as standard candles to measure cosmic distances. To the scientists' astonishment, these supernovae appeared dimmer than expected. This meant they were farther away than predicted. The universe was not just expanding, it was accelerating. A revelation that stunned cosmology and earned a Nobel Prize. Pause here and reflect. Is this not like life? We expect things to slow down, to fade. And suddenly they quicken. The cosmos itself turned our expectations inside out. Such reversals remind us that truth often lies beyond our forecasts. Today we know that about 68% of the universe is dark energy, 27% is dark matter, and only 5% is ordinary matter, everything we see. These numbers are staggering. We are the minority in our own cosmos. The majority is hidden, either as invisible mass or as a mysterious pressure-expanding space. What is dark energy? One idea is the cosmological constant, a term Einstein once added to his equations to keep the universe static, only to discard it later. Perhaps he was right after all, though in a way he did not imagine. Another possibility is that dark energy is vacuum energy, the energy of empty space, seething with quantum fluctuations, or perhaps it is something more radical, a signal that our theory of gravity is incomplete. Each hypothesis opens unthinkable doors. Philosophically, dark energy tells us that reality is not only hidden but dynamic. It grows, it accelerates, it runs ahead of itself. The cosmos is not a quiet stage, but a living drama, expanding faster with every act. Does this not resonate with our own restlessness? We too are propelled forward, sometimes without knowing why. Telescopes now map this acceleration with exquisite precision. Projects such as DESI, which charts millions of galaxies, and the European Euclid satellite, launched to study cosmic structure, are building three-dimensional maps of the universe's growth. Each new measurement refines our picture of dark energy, though its essence remains elusive. What if dark energy changes over time? If it weakens, the universe might one day slow and collapse. If it grows stronger, it could rip everything apart in a big rip. Galaxies, stars, atoms torn asunder. These are not science fiction plots, but serious scientific possibilities. To ponder them is to confront the fragility of existence itself. And yet, there is beauty in this fragility. Precisely because everything is temporary, every moment gains value. If the universe is rushing forward, then our lives are not meaningless, but part of this grand surge. Dark energy, though hidden, becomes a teacher of presence. Dark matter and dark energy together embody a cosmic paradox. One gathers, the other disperses. One shapes, the other dissolves. And yet, without both, there would be no story. The universe is written in contrasts, as if poetry were woven into its laws. Light and shadow, attraction and repulsion, order and chaos. It is in opposites that harmony arises. Imagine looking at the night sky and realizing that the stars are only sparks in a much larger play. The real drama happens behind the curtain, in the invisible forces that shape the stage. This is the humbling gift of science, to remind us that what we see is never the whole. In the next chapters, we will return to dark matter, to its quantum connections, and its possible links to black holes. But let us carry with us this thought. Dark matter and dark energy are not two separate mysteries, but two verses of the same cosmic poem. One verse holds us together, the other carries us apart. Together they sing the song of the universe. When we speak of dark matter, it may seem like a subject confined to astronomy, but its mystery is deeply connected to the quantum world, that strange realm where particles behave like waves, where emptiness seethes with activity, and where reality defies common sense. Perhaps here, in the smallest scales, lies the key to understanding the largest. Quantum mechanics teaches us that the vacuum is never truly empty. Even in the void, particles flicker in and out of existence, a restless sea of fluctuations. Could dark matter be linked to this quantum ocean? Could it be a manifestation of properties we cannot yet measure? One of the boldest ideas is supersymmetry. This theory proposes that every known particle has a heavier partner. The electron has the selectron. The quark has the squark. If such particles exist, one of them could be stable and invisible, making it a perfect dark matter candidate. Here, the quantum and the cosmic intersect. A particle born in the microcosm might govern the fate of galaxies. Another contender is the action, a particle first imagined to resolve a puzzle in the strong nuclear force. Axions would be nearly massless but could exist in such vast numbers that together they would outweigh everything we see. Detecting them requires immense instruments, resonators tuned to the faint frequency of the universe itself, like cosmic radios listening for whispers. There are also radical theories of hidden dimensions. What if dark matter is not in our space at all, but in extra dimensions we cannot perceive? We might see only their shadows projected into our world. This idea sounds like science fiction, but then again, so did quantum mechanics a century ago. Philosophically, the quantum view of dark matter reminds us that reality is layered. We see only one face, but behind it lie others. Dark matter may be the seam where micro and macro worlds meet, the bridge between atoms and galaxies. Pause and reflect. When we look at stars, we are also touching the quantum realm. For the particles that might make up dark matter are born of quantum laws. The infinitely small and the infinitely large are not separate. They are mirrors, reflecting the same mystery. Let us also be humble. Just over a century ago, people had no concept of quantum physics. They thought the atom was indivisible. Today, quantum rules. Power computers, lasers, medicine. Tomorrow, dark matter may become just as familiar, something woven into daily life. What seems impossible today may become ordinary tomorrow. Scientists also strive to unite quantum physics with gravity, to create a theory of everything. Dark matter may be the thread that ties them together. Perhaps it is not a separate substance, but a property of space-time itself, a quantum shadow we glimpse only through gravity's lens. And so we ask, can humanity ever fully comprehend the cosmos? Or will there always be a veil beyond reach? Perhaps mystery is not temporary, but eternal, woven into the structure of reality. If so, dark matter is not just a puzzle, but a reminder the universe is greater than any formula. Here is an image to hold, the universe as an ocean. We stand on its shore, seeing only the waves. We can dive, but no matter how deep, there will always be more beneath us. Dark matter is one of those depths. To accept this is not to despair, but to marvel. The unknown is not a void, but a promise. And is that not the essence of wonder? If all were known, what stories would remain to tell? It is ignorance that gives rise to science, just as darkness makes stars visible. In the next chapter, we will explore another frontier: black holes. Those enigmatic abysses where gravity rules absolutely. Could they be linked to dark matter? Could the most mysterious objects in the universe be made of or surrounded by the invisible? Once again, we will find ourselves on the edge of what we know, staring into the unknown. Whenever we speak of dark matter, we cannot avoid turning our eyes to another great enigma of the cosmos: black holes. These immense wells of gravity, where even light cannot escape, have long fascinated both scientists and storytellers. But could they also hold the secret to dark matter? Black holes are born when massive stars collapse, or when vast amounts of matter compress into a tiny region. Yet there is another possibility. Some black holes may not be the remnants of stars at all. They may be primordial, formed in the chaos of the early universe, just moments after the Big Bang. These are known as primordial black holes, and some scientists wonder whether they might account for dark matter. The idea is tantalizing. If the universe is filled with countless tiny black holes, too small to see directly, they could together provide the missing mass we seek. This would mean that dark matter is not a new particle, but an ancient population of invisible objects scattered through space. Testing this hypothesis is difficult. Primordial black holes could reveal themselves through gravitational lensing, bending the light of distant stars. They might also leave traces in gravitational waves, the ripples of space-time detected by observatories like LIGO and Virgo. Some researchers argue that unusual black hole mergers observed in recent years could hint at a primordial origin. Yet others remain skeptical. The evidence is ambiguous, the debate ongoing. Pause for a moment and think. How extraordinary it would be if the universe's hidden matter was made of its most mysterious objects, dark matter and black holes, two enigmas merging into one. Would that not be the ultimate cosmic irony? The story of black holes themselves is filled with doubt and discovery. When Einstein first developed general relativity, he did not believe such objects could exist. They seemed too extreme, too absurd. Yet mathematics insisted, and eventually observations confirmed them. Today we have even seen the silhouette of a black hole, captured by the Event Horizon Telescope. What was once dismissed as fantasy has become fact. Could dark matter follow the same path? Other theories suggest that dark matter particles might cluster around black holes, forming halos that could produce signals we might detect. If such particles annihilate each other, they might emit radiation. In this way, black holes become laboratories for probing the invisible. Philosophically, black holes and dark matter together challenge our sense of reality. They remind us that existence is not always visible, not always intuitive. The darkest phenomena may hide the brightest truths. Knowledge is born from paradox, light from darkness, understanding from mystery. Imagine billions of black holes roaming the universe like unseen nomads, each one a drop in the ocean of dark matter. We would not notice them directly, yet their presence would shape the cosmos, guiding galaxies and sculpting structure. To live in such a universe is to live in a world where the unseen dominates utterly. What lesson does this hold for us? That appearances deceive. We must look deeper, beyond the surface. The most important forces, whether in physics or in human life, are rarely visible. Love, trust, time. We cannot see them, but they define us. In the same way, dark matter and black holes shape the universe, without showing themselves. Scientists continue to search for signs of primordial black holes. Some gravitational wave events seem to involve black holes of masses difficult to explain through ordinary stellar evolution. Could these be whispers of the primordial past? We do not yet know, and perhaps that uncertainty is itself a gift. As long as we do not know, we are driven to explore. Think of it. A century ago, black holes were only equations, untrusted even by their discoverers. Today, they are among the most studied objects in astrophysics. Dark matter, too, may soon move from mystery to certainty, and when it does, our vision of the cosmos will transform once more. In the chapters ahead, we will return from the depths of black holes to the lives of the people who dared to chase these mysteries. For the story of dark matter is not only cosmic, but human. Behind every theory and experiment lies the courage of those who refuse to stop asking questions. And it is through their persistence that we inch closer to the truth. We have spoken of galaxies, black holes, and cosmic webs, but behind every discovery, behind every bold idea about dark matter, there are people. The story of science is not only equations and experiments, it is also courage, failure, persistence, and triumph. To understand dark matter, we must also honor the human side of the search. The tale begins with Fritz Zwicky in the 1930s. He studied the Coma cluster of galaxies and realized their motions were too fast to be explained by visible mass. He proposed the existence of dunkel materia, dark matter. Zwicky was brilliant but eccentric, often quarrelsome, and many dismissed his ideas. Yet time proved him right. He sowed the seed of a revolution. Decades later came Vera Rubin. In the 1970s, she carefully measured how stars rotate within galaxies. To her astonishment, stars far from the center moved just as fast as those near the core. According to Newton's laws, they should have slowed down. Her data was clear. Something invisible was holding the galaxy together. Today, her work is celebrated as a cornerstone of modern cosmology, but at the time, she faced skepticism and prejudice not only against her results, but against her as a woman in science. Her perseverance turned doubt into recognition, and she became a symbol of determination. Pause and reflect. Is this not the essence of the human spirit? To persist when others laugh, to believe in truth even when it is ignored. Science is not just knowledge. It is also bravery. Modern experiments, too, are filled with drama. Imagine teams working for years in underground laboratories, staring at screens of endless data. Most of what they see is noise, irrelevant signals. But hidden among millions of lines of numbers might be a single event, the trace of dark matter. The tension is immense. A lifetime of work might lead either to glory or to emptiness. Such patience requires more than intelligence. It requires faith. Some projects have ended in disappointment. Experiments have shut down after decades, without finding a single dark matter particle. Yet even these failures move us forward. Every negative result rules out possibilities and guides future searches. In science, failure is not the opposite of progress. It is part of the path. Think of the sacrifices involved. Scientists devote their lives, often without guarantee of recognition. They work in international teams, crossing borders, sharing ideas, sometimes living far from home. Their reward is not fame or wealth, but the joy of asking questions and seeking answers. This is what makes the story of dark matter so deeply human. It is not just a puzzle of physics. It is a story of passion. Consider also the beauty of collaboration. No single nation can solve the mystery alone. The hunt for dark matter unites scientists from America, Europe, Asia, Africa. They build shared experiments, exchange data, and debate theories. In a world, too, often divided, science becomes a bridge. Dark matter, invisible though it is, creates visible unity. Let us ask, what drives these people? Not money, not certainty. They know they may die without solving the puzzle. And yet they keep searching. Because for them, truth is worth more than outcome. To ask the question is already to honor the mystery. This is the true heroism of science. Sometimes the pursuit of dark matter resembles art. There are moments of frustration, of doubt, but also flashes of inspiration and joy. Like poets chasing the right word, or musicians seeking the perfect note, scientists reach for what cannot be grasped. They know that the act of searching itself brings meaning. Zwicky and Rubin are remembered now as visionaries, but their lives remind us that truth is never easy. It demands persistence against skepticism, courage against fear. Tomorrow, others will take their place, asking new questions, following new paths. But their journey is only possible because someone before them dared to look foolish. For the sake of truth, this human side of the story should inspire us. For if the universe is mostly dark, matter, then its discovery is not just about physics. It is about us, about our capacity to seek, to endure, to dream. It shows that curiosity is stronger than doubt, that unity is stronger than division, and that the unseen can guide not only galaxies but humanity itself. In the next chapter, we will look forward. What lies ahead for dark matter research? What new experiments and technologies are on the horizon? The future may hold the answers or deeper mysteries, but the spirit of the search will continue, because that is what it means to be human. We now stand at the edge of the present and gaze into the future. What awaits us in the search for dark matter? What new experiments and bold ideas might finally unlock this cosmic riddle? And how will such discoveries change not only physics, but humanity's view of itself? All around the world, new projects are rising. At Gran Sasso in Italy, the XENONNT experiment has begun, an upgraded version of its predecessors, filled with tons of liquid xenon to capture even fainter signals. In the United States, LZ stands as one of the most sensitive detectors ever built. In China, Panda X continues its vigilant watch. Each experiment is like a lighthouse in the dark, waiting for a passing particle to flash its light. Above Earth, space telescopes are joining the quest. The European Euclid mission, launched to map the geometry of the universe, will create detailed charts of dark matter through gravitational lensing. NASA's Roman Space Telescope will do the same, revealing how dark matter and dark energy intertwine. Together, these observatories act as cosmic cartographers, sketching the invisible landscape of reality. Beyond traditional detectors, there are daring new approaches. Physicists are building quantum sensors that might pick up the faintest whispers of axions, tuning their instruments like giant violins resonating with the universe. Others imagine using superconducting circuits, cryogenic crystals, or even entire networks of atomic clocks to detect subtle effects of dark matter passing through Earth. Each idea sounds like science fiction, yet laboratories are already turning them into reality. And then comes the most radical possibility. What if no particle ever appears? What if dark matter is not a substance but a flaw in our understanding of gravity? In that case, physicists will need to rewrite the laws that have guided us since Newton and Einstein. Imagine such a revolution. Gravity itself, the oldest and most familiar force, revealed as incomplete. Such a shift would reshape science as profoundly as relativity or quantum mechanics once did. Pause and reflect. Are we ready for such upheaval? Could we accept that even our most trusted truths may change? This is the essence of science, not clinging to certainty, but daring to adapt when the universe demands it. The future of dark matter research is also the future of collaboration. No single nation can solve the mystery alone. Projects span continents, linking universities, labs, and agencies. Data is shared across borders. Scientists of different languages and cultures work as one. In a fractured world, science shows what unity is possible when truth is the shared goal. Dark matter, invisible though it is, becomes a symbol of cooperation. What will humanity gain from solving this puzzle? At first, perhaps little practical use, but knowledge itself is power. Electricity was once a curiosity. Today, it drives civilization. Radio waves were once abstract. Now they connect the globe. Who knows what dark matter might one day inspire? Entirely new technologies, unimaginable today, could be born from its secrets. But even without immediate application, the discovery will transform us. It will remind us that we are part of a universe larger than imagination, and that truth is worth seeking for its own sake. This is the ultimate gift of science, to expand our horizons, to lift our eyes to the stars, to teach us humility. Picture our descendants a century from now. They will look back at our time as we look back at Galileo or Newton. They will wonder how we lived without knowing what the universe is made of, and perhaps they will smile at our crude instruments, our half-formed ideas. For them, dark matter may be as obvious as atoms are to us, yet their discoveries will not erase ours. Our questions, our efforts, our failures will have paved their way. The search for dark matter is not just about physics. It is about what it means to be human, to wonder, to strive, to reach beyond what we see. The universe may or may not reveal its secret in our lifetimes, but we search anyway because the act of searching is itself the answer. In the final chapter, we will step back and gather all the threads together. We will ask, what has dark matter taught us about science, about the universe, and about ourselves? For in the end, the greatest discoveries are not only about the cosmos, but about who we are in its vastness. We have reached the end of our journey. Dark matter has taken us through galaxies and clusters, through underground caverns and particle accelerators, through quantum mysteries and black holes. It has shown us not only the universe's hidden architecture, but also the resilience of the human spirit. Now, as we conclude, let us gather the threads and ask, What does this great enigma truly mean for us? First, dark matter teaches us humility. We once believed that humanity understood the cosmos, that what we saw was the whole. Yet now we know that everything visible, stars, planets, life itself, is only 5% of reality. The rest is hidden, untouchable, mysterious. This does not diminish us. It reminds us of our place. We are seekers, not masters, students of a universe larger than imagination. Second, dark matter inspires us. It whispers, "Look deeper. Do not trust only your eyes." This is not only a lesson for science, but for life. The most important truths are often invisible. Love, hope, meaning. They cannot be weighed, yet they shape everything. Dark matter is a cosmic metaphor for all that lies beyond appearances. Third, dark matter unites us. No one country, no one scientist can solve the puzzle alone. The search has brought together thousands of minds across continents, cooperating beyond politics or borders. In a world often divided, the invisible has become a symbol of visible unity. Is that not one of its greatest gifts? Philosophically, dark matter reminds us that mystery is not a flaw, but a feature of existence. We hunger for answers, yet perhaps answers are never final. Perhaps the universe is an infinite book, each page revealing more questions. Dark matter is one of those pages, a chapter not yet read. To live with mystery is to live with wonder. History teaches us that each generation faces its unknowns. Once, atoms were invisible. Once, galaxies beyond our own were unthinkable. Each discovery reshaped not only science, but humanity's vision of itself. Dark matter is the next horizon. One day, it too will become clear, and when it does, our sense of reality will change forever. But even before the answer arrives, the search itself is precious. To ask is to grow. To seek is to live. To reach for the unseen is to affirm that we are more than creatures of survival. We are creatures of wonder. And this, perhaps, is the deepest meaning of dark matter. It is not only a cosmic riddle, but a mirror reflecting our own thirst for truth. Imagine standing beneath the night sky. Each star you see shines because dark matter holds its galaxy together. Each constellation is possible only because of the invisible web beneath. And so the next time you look up, remember, darkness is not absence, it is presence. It is the foundation that allows light to exist. Let us ask one final question. What if dark matter is not only something to be discovered, but something to remind us who we are? A symbol of our ignorance, yes, but also of our courage. For to seek what we cannot see is the very definition of human greatness. And so, dear listeners, we end where we began, in wonder. We have walked through science and philosophy, through data and dreams. We have seen that the universe is larger, stranger, and more beautiful than we ever imagined. The journey is not finished. It will continue with those who come after us. But we can take pride in having asked, in having sought, in having dared. The cosmos speaks in silence. Dark matter is its quiet voice. We may not yet understand its words, but we know they are worth hearing, and that is enough to keep us searching. So when you next look into the night, see not only the stars, but the vast unseen that makes them possible. Let the hidden remind you that truth is always greater than appearances. Let mystery remind you that wonder is endless. And let dark matter remind you that even in darkness there is light. There is meaning, there is inspiration. The universe calls us forward. And though the path is dark, our steps are lit by curiosity, by courage, and by the eternal flame of wonder.